Good morning. This is Dr. Bobda, your new YouTube influencer. In fact, I decided to start making a series of short videos that I'm going to be posting on YouTube for you guys to grasp a little bit more concept of that we're teaching in class in details. So today I would like to start with my first video. And then in this first video, I would like to answer a question that a student asked me after the class regarding overflow. And in the class, I could already sense that students were having some issues understanding overflow. What does that mean? Okay, let's go straight to the point. Overflow. What does it mean we have an overflow? So I'll start this here by discussing the notion of a computer and the computational unit that we have in a computer. A computer performs operation. Let's say we want to do operation in computer. We can do the addition, we can do the subtraction, and then here we will have a unit that will allow us to do addition and subtraction. Then the computer will have a tiny other unit next to it that we'll call the control. And this control will be in charge of managing the unit that does addition and subtraction. Question is, where do we get the operand? So those are the values that we need to add and subtract. So those two values are coming from somewhere. In general, in a computer, we put those values in something we call registers. So a register is a tiny memory that can hold a value, small value, temporary until we decide to erase it. So a register will have a certain number of positions. For the sake of this example, we will assume that our register have 1, 2, 3, 4, 5 positions. And then we will need 2 of those registers to hold the variable that we're going to be adding, to hold the number that we're going to be adding. So each of those would be 5 position. And then this will give us something that is also 5 position that we will call here the result. 1, 2, 3, 4, 5 position. So this is how our computer process. We put 2 numbers in the 2 value, the operand, and then we track the result. And if this result, and then we can interpret this result now depending on what we would like to achieve, how we want to do this interpretation. So let me see, there's one, okay, there it is. So we have the 2 input operand, and then the result will go in this variable. Now let's assume we want to do a number, addition, subtraction, multiplication. What is the range that this computer can process? Assuming that we have only, that we have a range that is positive and negative number, this here would be the range of minus, where we could get number from minus 7 up to plus 8. What do I say? Minus 15, pardon, up to here plus 16. So this is the range of number that we'll be able to store in those registers here. So we will have 4 bits for the number and then 1 bit for the sign. Now let's assume that we have 2 numbers, and these 2 numbers is, we take the number 13 and then we'd like to add to the number 14. So one thing we can clearly see here is that the number 13 and 14 goes beyond the 16, the range that we can already represent with those 4 digits. And the representation of 13, we know how to do that. To represent 13, we take 13, we divide it by 2. It gives us 6, and then the remainder of 1 then we divide 6 by 2, it gives us 3, then the remainder of 1. We take the 3, we divide by 2, it gives us 1, then the remainder of 1. And then we take 1, we divide by 2. We divide 1 by 2 here, it gives us 0, and then the remainder of 1. I made a mistake. 6 divided by 2 give us, and then we have a remainder of 0 here. So that's my bad. So now the number 13 will have the value of 1, 1, 0, 1. That is our number 13. Then we do the same with 14. 14 will correspond to, so doing the same division, 14 divided by 2 is equal 7, and then the remainder of 0. 7 divided by 2 is equal 3, the remainder is 1. 3 divided by 2 is equal 1, remainder of 1. And 1 divided by 2 is equal 0, and then the remainder of 1. So the number 14 will correspond to 1, 1, 1, and then 0. So that's 14. Now, one thing we've seen in class is that those two numbers, to make them positive number, we need to append a 0 in front. So we will add a 0 here for the sign, and then 0 there for the sign. That way we have a representation in 5 digits. So how do we do addition? We take the two numbers now, and then we copy them. So we take these two numbers and put them, let me see, this, right. So we take these two numbers, and then we put them in the input register, and we'll check what the result will be. So now let's do that. I'll take the first number, which is 13, and then I'll put 13 in this register. That will be 0, 1, 1, 0, and 1. I'll take 14 in the other register. That will give me the 0, 1, 1, 1, and then 0. Now, we will do the addition of the two and then see with this addition what the result will be. So we'll take the two value here, do the addition, and see what the result here will be. So let's go. Now, the addition of those two numbers, we've seen in class how to do it. We will take the addition. We always start with the rightmost position, meaning this one. And then when we start, the carry in this position is always 0. So we put the 0 there as a carry. We do 0 plus 1 plus 0 gives us the 1 here. And then the carry for the next position is 0. Then we do the 0 plus 0 plus 1. It gives us the 1. And then the carry for the next position is 0. Then we do the 0 plus 1 plus 1. It gives us 0. And then the carry for the next position is 1. Then we do the 1 plus 1 plus 1. It gives us the 1 here. And then the carry for the next position is 1. We do now the 1 plus 0 plus 0. It gives us the 1. So one thing you can clearly see here is the following, is that even though the number here fits on 5 digits, it is the result of two numbers here that we've interpreted as positive number. So this here was positive because we had a 0 in front. This here was positive because we had a 0 in front. But this one gives us something that is negative because we now have a 1 in front. So the computer, when we do the operation, the result that we will have in the register will be 1. Let me use the red. So it's going to be the 1, then the 1, then the 0, then the 1, and then the 1. So clearly what we've done here is the following. We've done the addition of two numbers, positive number, and here we're getting a negative number. So many of you will ask now, but how do the computer know I told you at the beginning that the computer used those tiny memories here, and then the size of those tiny memory are fixed. In our case here, it's only 5 digits that we're using. The computer doesn't have more to capture an additional 0 here. That does not exist. And therefore, the computer is limited to interpret the result that we're getting. How do the computer know now? The computer now has this controller that will go and check here in order to figure out what is the sign of the result, what is the result look like. And what we see here is that the result has a value of 1, meaning that the number here is a negative number. So what we've done is the following. We add a positive number to a positive number, and then we got a negative number. So why is it like that? It is like that because the result that we got at the end is simply not able to fit. The result that we got at the end is simply not able to fit in the number of positions that the computer has to capture the numbers. And therefore, we have what we call here an overflow. So the overflow is not the bit that we have in here, but is what we need in order to get the result correct. In order to get our result correct, we will have to expand this here with a 0. And expanding that with a 0 means that our result will now fit only on 6 position. And that makes sense because 13 plus 14, that gives us the value here of 27. 27 is more than what we can capture in this set here. And therefore, we need 6 digits to capture this number here, to capture the number 27 for the magnitude and then the sign of that number. Okay, that's all I had for today. Hopefully everybody understands now the notion of overflow, adding 2 numbers, positive number, and getting a number here that the sign is different. You can say the same with subtracting 2 negative numbers and then having something that have a sign different will always lead to an overflow. So I gave the condition for getting an overflow in class, and hopefully you understand now why we're speaking of this notion of bit and 1 digit that is not possible for us to capture. So thank you very much.